Hello, good morning, students. In this class, we will see about the polynomials. What do you mean by polynomial? How does polynomial look? What do you mean by of a polynomial? What is the graphical representation of a polynomial? What do you mean by the zeros in graph for a polynomial? Okay, we'll see one by one topic. A polynomial, any algebraic expression can be a polynomial. For example, x. If I say x, it's a polynomial in one variable. Polynomial in one variable. Okay. But a linear equation, standard form of a linear equation in one variable is different. This can be a polynomial. Say x plus 2. Yes, it is a polynomial. Say for example 2x minus 3 is 0. Yes, it is a polynomial. Okay. So polynomial are nothing but they are the algebraic expressions having variables in it. Okay. So we have different polynomial types. For example, linear polynomial. What do you mean by linear polynomial? Linear polynomial means polynomial having degree 1. Having degree 1 for a variable. Example, if I say x plus 2, it is a linear polynomial. Variable is x and the degree is 1 by default. If you don't mention variable degree, it will be 1 by default. Okay. We have three defaults to assume. Let me explain it. When I write default, what are the defaults? When I write a x, we have three defaults for the x. One as a coefficient. If nothing is mentioned for a variable as a coefficient, one is default. Power or degree. This is a one if nothing, no power is mentioned for a variable. And the sign, default sign. Okay. For any variable, all these three things, if not mentioned, can be assumed unless mentioned. Okay. So coming to this x plus 2, the degree for polynomial x plus 2 is 1 because variable x has a power 1. When we say degree, what do you mean by degree? This is nothing but zeros or roots for that polynomial. Okay. What do you mean by root or a zero means they are solutions. They are nothing but the solutions of variable. Value which satisfies the expression is called a zero or a solution or a root. Any word can be used. If I say, for example, x plus 2 is equal to 0, what is the 0 for this polynomial? Then you just solve for x. That is your 0. Okay. If I say 2x minus 5 is a polynomial, what is the 0 for this polynomial? You just equate x polynomial to 0, solve for polynomial. This will be your 0. 0 is nothing but a value of the variable involved which satisfies the expression or equation. Okay. So linear polynomial means we will have the variable degree 1 in it. Okay. For example, p plus 2. P plus 2 is a polynomial in variable p whose degree is 1. Okay. Clear? Let's move on. What is the next set of polynomials? We saw linear polynomial so far. We'll move to the quadratic polynomial. Quadratic polynomial. Example, we can say 4y square minus 5y plus 2 equal to 0. Or we say just 4y square. I'll take the same example. Okay. Or we can say 3x square minus 3x. These are polynomials in variable 2 quadratic polynomials because all these have degree 2. When I say degree 2, just now we saw it is nothing but it will have two roots. Okay. So quadratic polynomial is a polynomial having degree 2 for a variable in it. Number of zeros, how many zeros it will have? Zeros is nothing but a root, right? So 2 only. Because 0 of a polynomial, please pay attention, zeros of a polynomial depends on its degree of a variable. Degree of a variable is nothing but the power of a variable. Let's see the cubic polynomial. For example, cubic polynomial. Cubic polynomial, let's see the example m cube minus 5m or x cube minus 5x square plus x complete also I can write, or x cube minus 5. All these are cubic polynomials because the degree, if you observe the highest degree of a variable is 3, highest degree. Okay. What if I have different degrees? Means variable having in this example, if you take x has power 3, x has power 2, x has power 1. What is the degree of a polynomial? We'll see in few minutes. So basically, when you when you're finding the types of polynomial, it depends only on the degree, highest degree of the polynomial. Okay, let's see the degree of a polynomial. If I say, let's see the example, polynomials and degree. Example, I'll say x square minus 2x. Degree is nothing but highest power of a variable. What is the degree? You can make out 2 is the highest power for a variable. X to the power 4 minus 3x square minus 5x. What is the degree for this? 4. M9 minus 5m3 plus 3. What is the degree for this? 9, because highest power of a variable involved, we have to get it. Though it is not in scope, I'll just explain. What if more than one variable is involved in the expression? Let's see. X square y plus x square y square plus 2xy plus 3. Okay. What is the degree for this? Because here variable is more than one. In this case, you have to find the degree for each term, then find the highest among the each term. Let's see, what is the degree of this constant? See, again, I'll say degree of constant is 0 because why? No variable in it, right? There is no variable. Or else, if you are not convinced, we can write x as 3 into x to the power 0, right? Because x to the power 0 is 1, right? Therefore, this becomes 3. So now what is the degree here? Though variable is not that, we can make it as x to the power 0. So degree becomes 0, right? Now, coming to this previous example where more than one variable involved, first add the degrees here. 1, 1 is there, so 2 is the degree. 2, 2 is there, 4 is the degree for the this term x square y square. X square y has 2 plus 1, 3 as the degree for this term. Then find the highest among this. Find the highest. among these term degrees. So degrees will become 4. Let's see one more example here. M to the power 4 n square m cube n plus mn cube plus 3. What is the degree for this? Same way. What is the degree of this term? 4 plus 2, 6. This is 3 plus 1, 4. This is 1 plus 3, 4. What is the degree for this? 0. Oh, pick the highest among the degree of each term. That will be the degree of the polynomial. Okay. Covered? Clear, right? So this is how we find the degree. Degree is nothing but a 0. 0 of the polynomial. Okay, let's move on. Let's find some zeros. Find zeros of below. Let's try. 2x plus 3. If this expression is given, find the 0 means we have to equate to 0. Okay. Solve for x. That is your degree. That is your 0. Okay. Let's see one more example. 5x minus 1 equal to 0. X equal to 1 by 5. Means by 1 you transpose then divide by 5. That is the 0. Clear? So what do you mean by 0 means? 0 means 0 of a polynomial. Okay. 0 of a polynomial means it is the value of a variable which satisfies the expression or equation. Okay, which satisfies the equation. That's called the 0 of the polynomial. Let's move on. What do you mean by geometrical meaning? Geometrical meaning of a 0 of a polynomial. Let's take a graph here. Say this is x-axis, this is y-axis. Axis will not terminate, so make sure you put a arrow here. Y dash it, sorry, x dash it is, and y dash. Okay. If I draw some line which represents some expression, we don't know that expression. Let's say this line represents y equal to 2x plus 3. Okay, we are not sure, but we assume it. Here, if I say 1, 2, 3, 1, 2, minus 1, 2, minus 2. Okay. Oh, this line cuts the x-axis at what point? Minus 1. Y-axis at what point? 1. Okay. So here, sorry, the point will be, coordinates of this point will be x as 0, y as 1. The coordinates of this will be minus 1 comma 0. Okay. 0 means, in graphical meaning, it is the x coordinate value. Okay. 0 for a graph is nothing but a x coordinate value. How many intersections it makes to the x axis, those are all the zeros. For example, here it has not cut the x axis in this point, it's a y axis intersect. Here it intersected at x axis at minus 1. So for 0 is minus 1 here. Please understand, when we say point p of xy, the first one always represents x coordinate, or it has another name, abscissa. The second one always represents y coordinate. It has another name called ordinate. Okay. So geometrical meaning of a zero of a polynomial means when we represent a polynomial in a graph, then the x coordinate value at which the graph intersects the x axis is it 0. Okay, we'll see a few more examples here. How many zeros it has? See, I'll put this as 1, this as minus 1. What is zeros for here? This graph minus 1 and 1 and two zeros are there. Okay, let's see one more example. This I'll make 2 and this I'll make 1. What is 0 here? 2 because the x coordinate value it is. Okay, forget about the y line y intersecting part. We are not concerned about that. Let's see one more example. So here how many zeros? How many zeros means two zeros because the graph intersected at 2 points in the x-axis. Here how many zeros? Only one because the graph intersected at 1 point on the x-axis. Here how many zeros in this line? The graph intersected at 1 point here, 2 point here, 3 point here, 4 point here. So total number of zeros is 4. However many intersects the graph makes to the x-axis, they are all called zeros. What are the zero values means? You just pick its value. For example, if I say minus 1 here, minus 2 here, 1 here, 2 here, 3 here, then what are the zeros for this means? Minus 2, minus 1, 1 and 3. Count of zeros means the point how many times the graph intersects the x-axis is the count of zeros. What are the zeros? Means the x coordinate value of those intersecting points. Okay, clear? So we saw what is the degree of a zero, what do you mean by zero, how to find a zero, what is its geometrical representation of a zero. Okay, now if you see, if I give a linear equation, say x plus 3 equal to 0, what will be the type of graph here? For a linear equation in one variable, type of graph will be always a straight line. Then if equation is a quadratic, okay, what is the type of graph? For example, x square minus 3x plus 3 equal to 0. What is the graph type for a quadratic equation? It's called the name parabola. Straight line, you know, this is a straight line. This is the linear equation representation. Parabola, we don't have idea, right? How does it look in the graph? So this is nothing but a parabola. U shape, maybe U shape, upwards, downwards, we'll see. Now, for example, see, this is a parabola types. Okay. So when parabola is like this, for example, if I write parabola, we just saw it is for quadratic equation, right? Ax square plus bx plus c equal to 0. Ax square plus bx plus c equal to 0. When does this type of parabola comes? When the value of a is greater than 0, we get this type of parabola. Okay, let's see another one. U downwards. When do we get this kind of parabola? When a is less than 0, then we get a downwards parabola. Okay, clear? We just need to know how quadratic equation, when we plot a graph, how does it look like? It looks like in the form of parabola. Okay, then we'll see how many zeros. We just saw how many zeros, right? We'll just cross check it. How many zeros here? How many zeros for this graph? It intersected at 1 point only, right? So 1 here. Let's see one more thing. How many zeros for this graph? How many intersects at x-axis? 2, right? Let's see one more graph. How many zeros for this graph? One intersect at x-axis, second one, third one. Okay. Let's see one more. How many intersects at x-axis? Is one only. Okay. So we'll see one more. How many zeros for this? 1, 2, 3, 4, 5. 5 intersects. So 5 is the zeros count. Yes. So we saw how many zeros we can find from the graph. Okay. Let's see the exercise here. One what is that? Polynomial, right? 2.1. Exercise questions we'll see. In the graph of y equal to p of x are given, find the number of zeros. Find the number of zeros. Okay. So first question, this is the graph. Just they are given a blank. So what is the zeros? Number of zeros is 0 because there is no graph plotted here. Second one, like this. So number of zeros here is 1 because we have one intersect in the x-axis. Let's see the third one. How many intersect the graph had made to the x-axis? 1, 2, 3. Number of zeros is 3. We'll move on. The fourth one is looks like this. Number of zeros is how much here? It is 2 because the 2 intersects. They have not asked what is the value of zeros here. They asked only the number of zeros. Let's see one. Another one is given. Okay. Here how many zeros? 1, 2, 3, 4. 4 zeros. Clear? We have tried the reason because the graph cuts the x-axis at 4 points. Okay. We have the last one in the exercise. Let's see that. I'll draw that. Okay. This is just one point here, not below. I'll rub this. So how many intersect it had made? This is one intersect. This is again like this. This is one intersect only. This is one intersect. So 3 zeros. If it had come down like this, then 2 intersects. It has made like this. Okay. So number of zeros is nothing but basically the x axis intersecting point for a graph. Clear? Zeros is nothing but a solution of the variable which satisfies the equation. Okay. Thank you.